Our new topic is circle. So we've got a circle here. O is called center, R is radius. How do you define R? From center to the circle, the length. So that's called R. This is R. So the angle between two radius is theta. So circumference, the length of this circle is 2 pi r. And the area of this circle is pi r squared. So those are the formulas that we should remember. If you are asked to find a piece of the length of a circle, that's called arc length of A to B, the length from A to B is equal to, that arc is facing to theta, therefore theta over 360 times, since we are dealing with length, 2 pi r, the circumference of the circle. If the question is find the area of the sector, where is the sector, area of the sector? It's here. This is the area of the sector. Let's call sector. This piece of the circle is called sector. Area of this sector is, again, theta over 360 times, since we are dealing with area, that's equal to pi r squared. Now, let's look at this question here. Okay. Let's choose a color. Let's choose brown. Okay, here we go. We got a piece of circle here. There are actually two circles. One is the radius is from O to A, and the other circle radius is O to B. It's just given a piece of it. So if you complete the picture, you will get one circle here, smaller circle, and a bigger circle. So the question is find the shaded area. First of all, I have to decide what to do here. The shaded area, we can find it as area of the greater circle minus area of the smaller circle. So here, area of the smaller circle. If you remove area of the smaller circle from area of the bigger circle, then shaded area will be left. So how do you find the area of the greater circle? Area of the greater circle, the sector of a circle. So what do we do here? We are going to use this formula here. What angle is given, but we forgot to write here. It's 30 degree. So that's going to be 30 over 360 times pi r squared. Let's take pi 3.142 times r squared. What is the radius of the bigger circle? So it is 8 squared minus. Again, now we are going to find sector of the area of a sector of the smaller circle. So that's going to be again 30 over 360 times, what will change? The radius will change. Times, what's the radius of the smaller circle? Is 5. So that's going to be 5 squared. Okay, let's find out. Let's find out what's the result here. So this is going to be 3.142 times 64 divided by 12 minus 3.142 times 25 divided by 12. So this is equal to 10.21. 10.21 cm squared. The answer is. Okay, now let's look at the second question here. The question is find the area of this segment. Area of this segment. So how do we find it? We can't use this angle because this is an inscribed angle. In order to use these formulas, your angle has to be a central angle. However, what I can do here, I can locate the center of the circle and draw two assistant lines, which is actually the radius of the circle. So then we form a new triangle here, which is OBC triangle. Now, if I can find this angle here, then I can easily find the answer of the question. Then I will use properties of angles on a circle. This is inscribed angle. Inscribed angle is equal to half of the angle that is facing on the circle. So what angle it is facing to? From C to P, C to B. So that's going to be 30 times 2. the size of the angle, it's going to be 60 degree. So CB is equal to 60 degree. Then the angle here is a central angle. Why? Because two lines met on the center. And the central angle is equal to the angle that it's facing to. So the angle here will be 60 degree. Yes. One information is missing here. What is that information? Where is the radius? The radius of the circle, I'm checking it, is 6 centimeter. It's given. Radius is equal to 6 centimeter. It is given in the question. We forgot to write it. Okay, so then in order to find shaded area, the area of the segment, what we have to do is we have to find the area of the sector and minus it, area of the sector and minus it from area of the triangle, isn't it? Area of the sector minus area of the triangle, it will be left the shaded area. What is area of the sector? Go back to the formula. What is the angle? 60. 60 over 360 times 3.142 times, what is r squared? 6 squared, minus area of the triangle. So how do we find the area of the triangle? All right, let's calculate area of the triangle here. What kind of triangle we have there? Here is 6, here is 6, here is 60 degree. So this is an isosceles triangle. Actually, it is an equilateral, but we are not going to use, we can, no problem. So if this is 60, this is isosceles triangle, then here will be 60 degree, here will be 60 degree. Why? 118 minus 60, 120 divided by 2, 60, 60. So it turns to be a equilateral triangle. That's also 60. Then in order to find the area of that, what we have to do is draw the height of the triangle. So that's the height. Remember, equilateral triangle or isosceles triangle height, divide the base into two equal pieces, right? So that's going to be 3. That's totally 6. So divided by 2, 3, 3. Then this is the what? This is the height. So I can use 2 ways to find h here. Either you can use trigonometry or you can use Pythagoras theorem. Let's use Pythagoras theorem. 6 squared is equal to 6 is, let's look at this triangle here. 6 is the hypotenuse. It's equal to 8 squared plus 3 squared. So 36 minus 9, 3 squared is 9. Move other side, negative 9. 8 squared. 8 squared is equal to 27, and h will be, what is root 27? Root 27 is equal to 5.1, 5.2 centimeter. Now, what is the area of the triangle? So area of the triangle is equal to base is 6 times height 5.2 divided by 2. Base times height over 2, 3, that makes 15.6 centimeters. So that's the area of the triangle. So it's going to be 15.6. Then what is the result here? This is going to be, when we simplify this 6 squared 6 is 6, 3.142 times 6 minus 15.6 is equal to 3.25 cm squared. The answer is